This lesson is a math lesson for a 3rd grade class at Ridgeview Elementary School in Hobart. It is over using the area of rectangles to model the distributive property. The students already know a little bit about distributive property and what it is in terms of addition and multiplication. They also know that how to find the area of rectangles. They know that they have to multiply length times width. So they are familiar with that. This is just a way to get them to break apart rectangles and use the distributive property to model that. So using the Envisions 2.0 math curriculum, these students will use their workbooks to follow along with the lesson. There are materials such as the quick checks that I use for pre and post assessment data that I'm not able to access right now, as well as a video that demonstrates the steps and rationale of breaking apart rectangles and using the distributive property. But I'm not able to access that right now, so instead I will model it on my whiteboard. So to begin the lesson, students do a solve and share problem in which they're given the area of, they're not given the area, they're given the dimensions of a classroom, and they're given the dimensions of a rug used to cover that classroom floor. So for this solve and share problem, students will be solving it independently and then turning to their shoulder partners to share how they solved this problem. Essentially, the problem goes like this. They're given a 9x8 classroom and then an 8x5 rug. And then they want to find out the area of this area right here. This is what they want to find because it's not covered. So the important part when modeling this problem to students, after giving them time to share their ideas and compare how they solved it with their partner, I will show them that they have to look at what this length right here is, and they have to understand that it is 4 because 5 plus 4 is 9. If only 5 feet of it is covered and the whole thing is 9 feet, there's 4 feet of it that is left not covered by the rug. So to find this, they will have to do 8 times 4. Students know that in a rectangle, the parallel sides are the same length. And so they will do 8 times 4, which they know is 32. Okay, so after this, we will move on to show the step-by-step video, but in this case, I will just model it using this anchor chart that I drew. For students, I find it's easier to keep math problems and steps to a minimum of 3 steps and a maximum of about 6 steps. Any more than that, and it starts to get complicated, and students have a hard time grasping each step. If you model it this way, students will be able to say, I understand step 1, but I don't understand step 2 or 3, or I'm having a hard time with the math on step 3. This is a good way to show it to them. So the first step is to draw the picture. This is the problem that is given in their book on their essential question problem. So it is an 8x7 rectangle. So first they have to draw the picture. I encourage them to draw pictures in all areas of math because it's very helpful for me, and I want students to be able to build that skill so that when they get to higher level math and problems that require more critical thinking, they have a more concrete reference for them. They're able to visualize math, and drawing pictures is the first step of that. Then they have to split it up. They have to split up their rectangle. In the problem in the book, they split up the side that is 8 units long by 5 units and 3 units. It's important to note that in the book it's done on a grid. I will give students graph paper to use during independent and guided practice to help them because some of my students are still having a hard time understanding that they have to multiply length times width to get area, and they tend to find themselves counting all the squares. So I will give that tool for them to use, but eventually I will try to phase it out. Then Step 3 is make your equation and solve. This is going to be the part that is going to really trip them up. Modeling things with equations is something that is more abstract than just modeling it with a picture and just doing the math in their head. If they have to model it using the equation form of distributive property, it's going to be a little bit tricky. So I'm going to point out to students while we're working through this problem that I'm going to ask them questions like, where did this 7 come from? Where is it on our picture? And I will show them our 7 is this side. What about this 5? This 5 comes from the length right here of this rectangle. And I might even have students label their pictures rectangle 1 and rectangle 2 if I see through like informal formative assessment that they really are not getting it. I will have them label rectangle 1 and rectangle 2, and then they can put the dimensions of rectangle 1 here and rectangle 2 here. And to get the area of the whole big picture, they have to add rectangle 1 and rectangle 2's areas together. So this will be the anchor chart that I will use and reference back to throughout guided practice and independent practice problems when it comes to helping students. So the students can turn to the guided practice page in their book, and the question asks, describe a way to separate a 6x6 rectangle into 2 smaller rectangles. Well, there's different ways that they can do this, so I will have students work with their shoulder partner to find at least one way that they can split up a 6x6 rectangle. And students really like doing this. They really like pairing and sharing and working with their shoulder partners. I think my students tend to get really nervous when they work independently and they aren't able to ask the person next to them questions. They also really like to help each other. I have a couple of higher ability students that really enjoy helping out the person next to them, and which is great for teaching them collaboration when it comes to doing project-based learning later on in school. So after about 3 minutes, I will have students, I will call on pairs of students to come up and share what they did, share what they drew. Again, always asking them to draw their picture first, because this is a skill that is super crucial for the iLearn test and for further standardized testing. It's a skill that they absolutely will need. So in the classroom, I will have them show their paper underneath the document camera. But since I don't have the document camera, I'm just going to show some of the other possible ways that students can split it up. So students might split it up into 3 and 3. Students might split it up into 4 and 2. And other students might split it up into 5 and 1. My students really like the 5 facts. They like that they can just count by 5s to find out what the next product is. So I have a feeling that this would be something that a lot of them would try to do, because their 5 facts and their 1 facts are super easy for them to remember. So then as each pair comes up, I will ask them the question that's number 2 on their guided practice paper that says, what multiplication facts describe the area of the 2 smaller rectangles you identified in exercise 1? So I'll rephrase this question by asking, what are the multiplication facts we would use to find the areas? Again, encouraging them to label their pictures rectangle 1 and rectangle 2, making sure that they circle a number so that they don't get confused and think that 1 or 2 is like a length or a measurement of some sort that they need to include in their problem. So I would ask them, so we know that the area of this whole big picture rectangle is 6 times 6. That's how we would find it. But how are we going to model it using our 2 smaller rectangles? What multiplication facts do we see? To kind of help them out, I'll cover up 1/2 of their rectangle, and I will encourage them to do the same thing too. Cover up half of your rectangle. What do you need to multiply to find the area of this rectangle? That's right, 6 times 3. I'm going to put it in parentheses so I don't get confused. 6 times 3 is how we find rectangle 1. What about rectangle 2? I will cover up rectangle 1 and see that it will do 6 times 3 again. Now we know that the area of both of these, if we add them together, is the same as 6 times 6. So we put a little plus sign there because 6 times 3, this area, plus 6 times 3 is going to give us the area of the whole rectangle. Okay, I will do this for each different square, each different rectangle model that the students bring up. Remembering to encourage them to really bullet rectangle 1 and rectangle 2, and then adding them together to get the whole big rectangle. Then in step 3, it gives us a picture, and it already split up. It already did steps 1 and 2 of the anchor chart that I have here. So they just need to do step 3. It says complete the equation that represents the picture. Okay, and it gives us the rectangle. Shoot, I hope this works. So it gives us the rectangle, and the rectangle is a 6 by 5 rectangle. 6 by 5. Oh my gosh, of course. Let's hold it like this. So they give us a rectangle. It is 6 by 5, but they split up the 5 as it looks like this. They split it into 2 and 3. And then they give students part of the equation, but they have empty boxes that they need to fill in. This is where it's going to really be confusing for them. This is where they're really going to struggle because they are going to not know what numbers to plug in. They're going to get confused by the boxes and confused that their picture doesn't look like this picture, and it's going to be confusing. But I can walk them through step by step. So times 2 plus blank, and then it gives them one more step where it's blank times 2 plus 6 times blank. Okay, this is where you encourage them to cover up and think about where each one is. So what's going to go in this box? 3, because we're doing 6 times 5, and then 6 times 2 plus 6 times 3 is going to be the same. Okay, and after this we will work through the 2 independent practice problems together because they're going to really need a lot of guided practice on this equation part, and then I will send them to do their the rest of the independent practice problems on their own. Again, they will have graph paper to help them. They will have this anchor chart to help them. For formative assessment, through each step of the independent practice, I will ask students to give me a thumbs up, thumbs middle, thumbs down, or I can have them do a 1, 2, 3, or 4. 1 being that they completely don't understand any of this, 2 being they understand a little bit but might need help, 3 being they can understand and do it on their own, and 4 being that they can understand, do it on their own, and teach somebody else to do it. From then, I can pull the students that are showing 1s and 2s into a small group with me, and then we can work through all of the independent practice problems together. After students complete their independent practice, they will do the quick check, which is online on their Chromebooks through the Pearson website, and then I will use this data to determine if we're ready to move on to the next lesson where they're breaking apart irregular shapes into rectangles.